Hello everyone, welcome to my channel. Today we are solving flat fill, so let's dive right into it. So we're given an image that is represented by m times n integer grid. And m of I and j represents the pixel value of the image or the color. And we're also given three integers, SR, SC, and color. And SR, SC would be the starting point, and the color is basically the new color that we are going to insert. And we have the starting point, SR and SC, and we are going to move forward directionally and find any indices that have the same color as the original color, which is at the starting point, and we're going to change all of the color to the new color that's given. So for example, example 1, we have SRSC as 1 and 1, so we're going to start there, and we're going to move forward directionally, so we can move either up, down, left, or right. And we're going to find the same value as the original value, which is 1, and we're going to change all of this to 2. So we can visit this, and we're going to check its neighbors and find the original value in its neighbor, find the original value, its neighbor, and find the original value. We cannot change this one, even though it's the same value as the original color, because we cannot visit it forward directionally. We cannot move diagonally here. So we're going to use a depth first search for this problem. And let's use this example. So we have SR and SC as 1 and 1. So the starting point is here. We're going to also keep a track of the original color, which is the value at the starting point. So in this case, 1. We are going to change the color from 1 to 2. We're given new color 2. So first thing we're going to do is we're going to change the color at the starting point. And then next we're going to check its neighbors that we can visit. So for directions, up, down, left, and right. And then we're going to find the ones that have the same value as the original color. So in this case, up and left. And we're going to visit one of them. So let's visit up first. So then we can do the same operation. We're going to change the number to the new color, and then we're going to check its neighbors next. So we're going to check 4 directions, and some directions will be invalid. We're going to have invalid indices, or we're going to have values that it's not the same as the original color, so we can ignore those. So if we find the original color, then we are going to visit that, and then change the number to the new color and check its neighbors, and none of these are valid. So let's go back to the previous one. We had another valid index that has the original color. So we're going to visit there, change the number to 2, check its neighbors. Some of these are not valid, and this one is valid. It has the original color 1. So visit there, change the color, and check its neighbors, and if there is a valid index, change the color to the new color. And at the end, we only have either invalid indices or the values that is not the same as the original color. So it will eventually end. So let's write up the solution. So first thing we're going to do is we're going to have an array outside of the method. We're going to have a public final. It's going to be a 2-dimensional array, and we're going to have the direction. We're going to keep the direction that we can go to. So we have 4 directions. So we're going to have 0, 1, 0, -1, and 1, 0, and also -1, 0. So this here is basically the 4 directions that we can go. We are going to have x and y axis. So this basically here is moving up by 1 on the x-axis, and moving down by 1, moving to the right by 1, moving to the left by 1. So we're gonna use this in a for loop later. We're also going to keep track of the original color. Since we're going to change it, we will have to keep track of it. So we're going to have int original color. We're going to make it -1, so that we will know that the first time it has not changed, but other operations we can ignore it. So the first thing we're going to do in the function is we're going to assign the original color, and we're going to check if the original color is -1. In that case, it hasn't been assigned, so the original color would be the value at the starting point, which is image of SR and SC. And we're gonna do recursion to do this, but from the second time, this original color will have some value other than -1, so this will be ignored. And then we're going to change the value at the starting point. So we're going to do image at SR and SC would be the new color that's given. And then we're going to check its neighbors for directionally. So then we can use this directions array. So we can do a for each loop. So for each direction, and we can do int direct or there, and in the directions array, we are going to check a new x value and the y value, or new row and new column. So the new x value will be the current x value, which is SR, plus the direction at index 0. So this was the x value. So we're going to add that, and we're going to do the same for the y value. We're going to add the current column number SC plus the direction at index 1. So in this case 1. So we're going to add 1 to the y value. So now we're at here at its neighbor. And after that, we need to verify if the x and the y value are valid, because in some cases it can be invalid. It can be either -1 or over the length of either the row or column. So we're going to check that. So we're going to check if the x value is valid. So in this case, it needs to be greater than or equal to 0. And also it needs to be less than the length of the column. And we need to do the same for the y value. It needs to be greater than or equal to 0 and less than the number of rows this have. So image of 0.length. And we're also going to check if the indices are valid. We're going to check if the value there at the new x and y value is the same as the original color. So we are going to check if the image at the new x and y value is the same as the original color. And we also need to check if the value at the new spot, new x and y, is not already changed. So image at x and y is not the new color already, because we want to avoid stack overflow or infinite loop. So we need to check that as well. So if that's the case, then we want to go to that neighbor, change its color, and then check its neighbors. So we can use this function again. So we're going to call float fill array is the same And SR, for the SRSC, we can use the new indices, and the new color is the same, so we can call that. So it just keeps calling its function as long as you find a valid index and that has the original color. And after all the operation, we can just return the image, the array that was given. So that's basically it. Let's see if this works. Alright, so this was Flat Fill. Thank you for watching.